to close out this section of videos, we're going to look at some specific problems that the student had requested. So we'll begin with this one right here. Yeah, 8r, parentheses 8r minus 3 minus parentheses 7r plus 1 is equal to negative 6. So in this problem, we have parentheses, but also notice that this minus sign is between them, between both parentheses. So there's always, when that's the case, there's always like an imaginary 1 there. Now, the 1 does exist. The reason why we say imaginary is because it's never really illustrated in problems. So now we look to combine like terms. When we're working with parentheses, we will have to solve what's inside. We see that we have a variable and a constant, and then in the other set of parentheses we have a variable and a constant, and on the right hand side we just have a constant. So we can't combine like terms in this problem, unfortunately. But we can apply the distributive law, namely to this part right here, where we're going to distribute this minus 1 to both sides. So we're going to do that. We have 8r minus 3 parentheses, and I have minus 1 times 7r, and then we have minus 1 times 1 is equal to negative 6. 1 times 7r gives us minus 7r. 1 times 1 gives us a minus 1. Now, since we weren't able to really solve anything within these parentheses, we're going to just pull everything out. Now, for the first time, we have a problem where we can actually combine like terms. This is pretty exciting. What we're going to do is I'm going to label these like terms. So variables are going to be represented using circles, and then constants are going to be represented using squares or rectangles. So we can combine variables together. So 8r minus 7r, that gives us just r. Now we have minus 3 minus 1, that gives us negative 4, or minus 4, is equal to negative 6. Next we want to solve for our variable, so we're going to apply the addition of both sides. So I'm going to add 4 to both sides. We get that cancels out, and I have r is equal to negative 2. Now this is our solution, but for us to be 100% certain that this is our solution, we must plug this in back to the original equation and then solve it. But I will leave that as an exercise for you. So with that in mind, we're going to look at one last problem. Let's see. One last problem. Yeah, look at one last one. That a student left. Can't really read my handwriting, unfortunately. So I hope I wrote it down correctly. Let's see if I have it already. Oh, okay. So I got it. So in this next problem we have 5.2x plus 3 times parentheses x plus 1 is equal to 5x plus 4. Now, this one seems like there's a lot going on, especially with that decimal in place. So, this may seem really strange, but what I would like to do is multiply this whole equation by 10, just so I can get rid of this decimal value. So remember, this acts just like the distributive property, where this gets multiplied to each component. Now, one thing I'd like to point out is that this 10 is not going to be distributed to the inside of this parentheses. It's just going to be distributed to what's outside, because eventually what we're going to do is apply the distributive law to the inside of it. So doing that and just not going directly into it will save us a lot of conflict in the long run. So I'm going to have 10 times 5.2x plus 10 times 3 parentheses x plus 1 is equal to 10 times 5x plus 10 times 4. Remember, when I'm multiplying by a decimal by a multiple of 10, we just move the decimal point over to the right dependent by how many zeros. We have 1 0, so this is just going to move one space over. So we have 52x plus 10 times 3 gives us 30. X plus 1 is equal to 10 times 5x gives us 50x plus 10 times 4 gives us 40. Next, we want to distribute. So we have 30 gets distributed to x and gets distributed to 1. So I have 52x plus 30 times x plus 30 times 1 is equal to 50x plus 40. We end up getting 52x plus 30x plus 30 is equal to 50x plus 40. Now, we want to combine like terms. So we see that on the left-hand side, we have a variable, and then I have a constant. On the right-hand side, we have a variable and a constant. So the only thing we can combine is on the left-hand side, namely the variables. 52 plus 30 gives us 82x is equal to, plus 30 is equal to 50x plus 40. Now, you want to begin by isolating the variable, getting the variable all onto one side. And as I stated before, my preference is to move the smaller variable over to where the larger variable is. So we're going to begin by subtracting by 50x to both sides. This gives us, this cancels out. We have 82 minus 50x, and that gives us 32x plus 30 is equal to 40. Next, I want to have the move the constant to isolate the variable, so we're going to subtract by 30, and by doing so we get 32x is equal to 40 minus 30 gives us 10. Next, we want to divide over by both sides, and we have x is equal to 10 over 32. Now we have a fraction. This is not really the nicest solution, but it is our solution, and we want to get it in lowest terms. So we want to reduce this fraction. Both values can be reduced by dividing by 2. So if we divide by 2 to both sides, 10 divided by 2 gives us 5. 32 divided by 2 gives us, I believe, 16. And this is our final answer, 5 over 16. So in order to check this answer, you must plug this guy back into our original equation. It could either be this one up here or this one, if we need to these two, because multiplying this top equation by 10 didn't really change it, because as we recall, the equality solving tools, when applied, keep this balance. And with that, this ends our section on utilizing these equality solving tools, and where we applied them to some examples.